not the little one, not the other one. Right? Some other theorem. Some other theorem. If f of c is a local max or min, then f prime of c is 0 or undefined. That is extremely important. That's going to carry through for the rest of chapter 4 for sure. All right? We're going to be using this result over and over again. So, if we want to find maxes and mins for a function, what we're going to do is we're going to take the derivative and set it equal to 0 and solve. Or we're going to take the derivative and see where it's undefined and solve. Solve for that value. Those values are the only ones that can be maxes or mins. They don't have to be though. There could be no maxes or mins. But they're the only ones that are going to be if there are any. Okay? So even though this reads forwards, if this, then that, but we're using the result. Right? We're using this. So just because it's 0 undefined does not mean it is necessarily a max or min. Right? The converse is not necessarily true. But this does imply there are no other max or min locations besides the ones that do this to the derivative. There's no other ones out there. All right? Yeah. Give you a stupid example. Let's take f of x very quickly. F of x equals 4x squared plus 3x minus 2. Okay? I want to try to find where this thing has a max or min. Find all is going to now be called critical points. Find all critical points of f of x. What's a critical point? A critical point is one that does this to the derivative, right? Critical point C, if such and such, okay? A critical point is a number which causes the derivative to be undefined or 0, all right? And those, according to Fermat's theorem, are the only possible locations of max and mins on our functions, all right? So I want to find all the critical points of f of x. What am I finding when I find all the critical points? I'm finding, another way of saying that is all possible all possible locations of max or min. That's what I'm finding. Okay? And Justin has said correctly, in practice what we're doing, we're finding all zeros of the derivative. Not just the zeros, right? Because it's where the derivative is 0 or undefined. Find all the zeros of the derivative, or and, really now, and, we're doing both, and where it is undefined. Okay? Where the derivative is 0 or undefined. So I don't care about the 0 of the function anymore. I don't care where its x-intercepts are. I want to know the 0 of the derivative. What's the 0 of a derivative? I talked about this before. At A and B here, you've got a 0 for a derivative. A 0 derivative means you've passed through a horizontal asymptote, correct? A horizontal tangent, correct? The 0 derivative means 0 slope. Okay? If you have a 0 slope, that means you're passing through a horizontal tangent. So, in many cases, not all, right? Because this is not, it doesn't work backwards, right? It doesn't imply backwards. But in many cases, like in the picture I've drawn, that will imply that you've got a local max and a local min, okay? Where the derivative is 0. But there are cases where derivative is 0. I want you to remember this one. Right? derivative is 0, right at 0. It goes through very swiftly, right? Right there, it has a horizontal tangent. Is it a local maximum there? Is it a local min there? Nope, neither one, right? Matter of fact, this function is always increasing. Since it's always increasing, it can't possibly have a local max or min. Being this continuous increasing, right? All right. So not every horizontal tangent is necessarily max or min, but the only max and mins you're going to find are from those horizontal tangents, or where the derivative doesn't exist. Why where the derivative doesn't exist? Because you could have other cases. You could have something very strange, like maybe it goes down here like that, pow, and it comes back up again. So that's certainly a local min, but the derivative doesn't exist there. The derivative's not 0 there, for sure, right? But the derivative would not exist there because the slopes are not approaching the same thing. They're approaching different things from each side. So the derivative does not exist there, but certainly it's a local min. So finding where the derivative does not exist can also sniff out where you might have local maxes or mins. Okay? All right. So now, you should have the intelligence and wherewithal to tell me right now, where is the location, without resorting to calculus whatsoever. You should be able to tell me the location of a max or a min on this thing. What's that? No derivatives. What did you say, Lou? Negative 3 over 8. X equals negative 3 over 8. How do you know that, Lou? No derivatives. No derivatives.
Nope.
No derivatives. How do you do without derivatives?
Don't you just like, can't you just multiply?
B over 2a.
Good. This is the same as negative b over 2a. What is negative b over 2a for a quadratic?
Max or min?
It's the location, it's the x location of its
Vertex or?
vertex. And the vertex of a parabola is its lowest or highest point, right? So in this problem, without any calculus whatsoever, you know algebraically that the location of it opens upwards, so it's a min, right? Okay. So you know this is the location of a local min. X equals negative 3/8. Agreed? Everybody agree with that? Okay. Now we'll use calculus to show the exact same result. Because not everything has vertex in this world, so the calculus way is a little broader, right, in application. All right, so what are you going to do? Lou said take the derivative. F prime is what? Well, it looks like 8x plus 3. So now what do I do with this? I've got to find out where it's 0 or undefined. But wait, it's a polynomial, so it's never undefined, right? So all I got to do is set equals 0 in this case. Usually, when you find something is undefined, you're dealing with a rational function, a rational expression for your derivative, right? Then the bottom, if the bottom were to be 0, that would be where it's undefined, and we want to know about that. So this is just a polynomial, or you're doing set equal to 0. Okay? So it looks like you subtract 3 and divide by 8, you get x equals negative 3/8. And now we know, still nothing, but we've found a critical value, right? CV, critical value. It could be a max, it could be a min, it could be nothing. Just finding the critical value